July 1942. The world's skies were no longer dark. They were electric, alive with invisible signals no human eye could see. From the cliffs of northern France to the dunes of the Dutch coast, giant steel antennas turned slowly in the night, sweeping the heavens like watchful eyes. For the first time in human history, man had built a machine that could see without light. Its name was radar. And for every Allied airman flying into that storm of steel and fire, it was a nightmare. The promise and the peril. Radar, radio detection and ranging, had been born out of British ingenuity, but by 1942, Germany had perfected it. The Luftwaffe's radar web stretched across occupied Europe, linked by high-frequency beams that could pick up an incoming bomber from nearly 200 miles away. In the skies over Europe, darkness no longer offered safety. Every night, hundreds of young men from Britain, Canada, and the United States climbed into their bombers, knowing that somewhere out there, unseen operators were already tracking them, plotting altitude, bearing, speed. Inside those radar rooms, the glow of green cathode tubes painted a deadly map. And when a faint blip appeared on the screen, a finger would rise, a headset would crackle, and an order would echo through the bunker. Target approaching, Vector 340. Fighters, scramble. Moments later, engines would roar to life, and another Allied formation would disappear into the black. Fear above the clouds. By mid-war, RAF Bomber Command faced losses that were, frankly, unsustainable. Some missions saw 1 in 3 aircraft never return. The men knew it. They joked about it. They made coffee stronger. They smoked too much. They signed their names on the mess hall wall before takeoff, just in case that was the last mark they'd ever make. But none of it dulled the fear, the bone-deep knowledge that radar had changed everything. The Germans called their early warning system the Kammhuber Line, a vast network of overlapping radar sectors, each guarded by searchlights and night fighter bases. It was efficient, clinical, and brutally effective. The moment an Allied bomber crossed the channel, its position could be passed from radar post to radar post, guiding twin-engine fighters straight to it. No matter how high they flew, no matter how dark the night, the Germans could see them.
The unsolvable problem. Back in England, the Air Ministry's scientists were desperate. They tried chaff, thin strips of foil meant to confuse radar. They tried new flight routes, new altitudes, even wooden decoys. Nothing worked for long. The radar beams cut through darkness and deception alike, a constant reminder that the enemy was always watching. By the summer of 1942, Bomber Command's top brass knew something had to change, or the air war over Europe would be lost. But the answer wouldn't come from the grand halls of Whitehall or even from the laboratories of Cambridge. It would come from a man who wasn't supposed to matter, a quiet, unremarkable engineer in a factory by the sea. His name was Harold Bishop, an ordinary man in an extraordinary war. Bishop wasn't a soldier or a scientist in the glamorous sense. He was a paint engineer at the Royal Aircraft Establishment in Farnborough, One of those grey, practical men who worked 12-hour days mixing chemicals that others ignored. His job? Keep Allied bombers from corroding under salt, sun and stress. Nothing heroic about that. He wasn't designing engines or inventing new radar. He was worried about paint. Yet history turns on the smallest hinges. And on one wet afternoon in the autumn of 1942, that hinge creaked open. The accident. It began with a shipment of magnesium powder, common enough in wartime factories. Bishop's team used it to create a new kind of reflective coating, meant to make bomber undersides harder to spot by searchlights. But someone, maybe Bishop himself, maybe a new apprentice, misread the proportions. The batch came out wrong. The pigment clumped. The mixture looked off-color, dull, almost greasy. When they sprayed it onto a test panel, it didn't shine like it should. It absorbed light instead of reflecting it. A failure. Or so they thought. He logged it as a rejected formula, marked R134, and pushed it aside. But something about it bothered him. When he looked at it under certain lamps, it seemed to swallow more than just visible light. It dulled the reflection from metal instruments too, almost as if it was drinking in radio waves. He didn't know it then, but that stupid paint was about to rewrite the rules of aerial warfare.
The moment of discovery. A few days later, Bishop's supervisor ordered a batch of the failed paint used anyway. Wartime shortages meant nothing could go to waste. The next time a reconnaissance aircraft came in for maintenance, the crew applied R134 to several panels just to use it up. When the plane flew its next test sortie, ground radar operators noticed something strange. The aircraft barely appeared on their screens. At first, they assumed the equipment was faulty. Then they tested it again and again. Each time, the radar return was weaker than before. That dull, greasy paint was absorbing radar instead of reflecting it. Harold Bishop's accident had created the first primitive radar-absorbent coating in history. The reaction. In any other war, it might have gone unnoticed. But 1942 was a year of desperation. When the test reports reached the Telecommunications Research Establishment, the nerve centre of British radar science, they didn't laugh. They sent a car for Bishop. Soon he was standing in a room filled with men whose names would never appear in history books, mathematicians, physicists, radar operators, all staring at a small painted panel propped under a radio beam. The oscilloscope's line barely moved. The room fell silent. For a moment, nobody spoke. Then one of the scientists turned to Bishop and asked quietly, "Do you have any more of this paint?" That single question would set in motion a secret collaboration between the RAE and the TRE, one so classified that even most pilots would never know it existed. A war of shadows. As the months passed, Bishop's formula was refined, tested and applied, first to small areas of reconnaissance planes, then to full bomber surfaces. It wasn't perfect, but every decibel of radar reduction counted. The coated bombers began slipping through portions of the Kammhuber Line almost undetected. By the spring of 1943, German radar operators were reporting ghost echoes, fleeting blips that appeared and vanished before they could be tracked. Some officers thought it was equipment failure. Others believed it was sabotage. No one imagined that Allied scientists had found a way to turn radar blind. The turning tide. The breakthrough came just in time. That summer, the Allies prepared for one of the most daring air offensives of the war, Operation Gomorrah, the bombing of Hamburg. For that mission, selected bombers were coated with Bishop's latest paint mixture. Combined with chaff clouds and electronic countermeasures, it produced chaos in the German defenses. Radar screens flickered, overloaded by false returns. Fighters scrambled too late. Searchlights stabbed empty sky. The results were devastating. Hamburg burned for 8 nights straight. Tens of thousands died. The Luftwaffe's radar network, once the pride of Germany, lay in ruins. And yet, in the official reports, there was no mention of Bishop, no note about R134, just a brief line. New surface treatment appears to improve radar invisibility. Legacy of the Invisible. Harold Bishop never became famous. After the war, the project was classified and quietly forgotten. Its research absorbed into later studies that would one day lead to the stealth technologies of the Cold War. But every stealth aircraft flying today, from the F-117 Nighthawk to the B-2 Spirit, owes something to that mistake in a paint shop in 1942. The story of the stupid paint is a story of accident and genius, of how one man's curiosity saved countless others. And as we peel back the layers of this forgotten history, we begin to see that victory in World War II wasn't just forged by courage in the skies, but by quiet minds working in the shadows.
By late 1943, radar had become the new front line of the air war. It wasn't just about aircraft anymore. It was about the invisible battlefield that surrounded them, the electromagnetic spectrum. The Allies called it electronic warfare. The Germans called it Funkkrieg, the radio war. And in that war, every signal, every echo, every invisible wave was a bullet waiting to be fired. The German edge. In a concrete bunker outside Rotterdam, Luftwaffe technicians hunched over glowing screens. Their eyes never left the trace lines that swept slowly across the glass. These men, known as Funkmess operators, were among Germany's elite. They didn't fly, they didn't shoot, but they could decide who lived and who died. Each radar pulse they sent into the sky painted an unseen picture of bombers approaching the coast, of flak bursts in the night, of formations weaving to avoid the searchlights. To the operators, these were not men, they were blips, tiny spots of light that meant hundreds of lives. And for a long time, they had the upper hand. Even as Bishop's secret coating began to take hold, the German network adapted. New frequencies, new equipment, new filters. The race for invisibility had truly begun. Britain strikes back. Inside a nondescript brick building in the English countryside, another war was raging, one that the public never knew about. This was the Telecommunications Research Establishment, or TRE, near Malvern. Every night, mathematicians and radio engineers worked under blackout curtains, trying to outsmart an enemy they could not see. One of those scientists was a young Welsh physicist named Joan Curran. She had joined the project after working on radar echo tests with her husband, and she brought something that seemed absurdly simple, yet utterly brilliant. Her idea was foil, the trick called window. Curran proposed that aircraft could drop clouds of thin aluminium strips, each cut precisely to half the wavelength of enemy radar beams. The strips would drift slowly down through the sky, reflecting radar signals and creating false echoes, hundreds of them. On radar screens, it would look like an entire squadron or an endless swarm of ghost aircraft. At first, senior officers refused to try it. They feared that if the Germans saw through the trick, they could copy it and use it against London. But desperation breeds courage. By mid-1943, Bomber Command approved the plan. The operation was codenamed Window. The night Hamburg vanished. On July 24, 1943, a British bomber crew opened a small metal box and pulled out bundles of shiny strips. Each man carried several, cut to lengths that matched the frequencies of the Würzburg radar stations below. As they neared the German coast, the navigator gave the order, "Drop window." Bundles of foil burst open in the wind, scattering millions of fragments that glittered in the moonlight as they fell. Within seconds, German radar screens exploded into chaos. What had once been a clean, steady display turned into a storm of static. Operators shouted over each other. Searchlights swept wildly across empty sky. Fighters were scrambled in the wrong direction. To the Germans, it looked as if hundreds of bombers were coming from every angle. In truth, only a fraction of them were real. For the first time in the war, radar had been blinded by nothing more than tinfoil. The human cost. The success of Operation Gomorrah owed much to Bishop's radar-absorbent coating, but it was Window that finished the job. The combination was devastating. Hamburg burned for 8 days. Tens of thousands perished. The city's heart, its docks, its warehouses, its homes, was reduced to ash. Even the crews who carried out the mission were horrified by what they saw from above. Entire blocks glowing red, rivers of fire, the smoke so high it reached their altimeters. One pilot wrote afterward, "We had blinded their radar, yes, but we had blinded ourselves to mercy." A silent revolution. What Bishop and Curran achieved, independently, unknowingly, was nothing less than the beginning of the stealth age. One by accident discovered how to absorb radar. The other, by design, discovered how to confuse it. Together, they reshaped the future of air combat. By 1944, every major Allied bombing raid used some combination of radar absorption, reflection, and deception. The air had become a canvas of illusions, painted not in smoke or flame, but in invisible waves.
Countermoves and counter-countermoves. Of course, Germany struck back. Scientists at Telefunken and Lorenz developed new radar sets with frequency agility, able to jump between bands to pierce through window. They experimented with infrared tracking, acoustic sensors, even crude computers that could predict bomber paths. But the Allies were already 2 steps ahead. At Baudsy Manor and Malvern, teams developed Carpet, Mandrel, and Jostle, massive airborne jammers that could drown German radar stations in noise. By 1944, Allied bombers no longer flew blind. They carried entire electronics officers whose sole job was to monitor the invisible battlefield. The ghost over Normandy. On the night before D-Day, radar was once again the weapon of choice. But this time, deception was the strategy. The Allies launched Operation Glimmer and Operation Taxable, fake invasions carried out entirely through radar illusion. Small fleets of boats equipped with radar reflectors and chaff sailed up and down the French coast, imitating the radar signature of a massive amphibious assault. From their screens, German commanders saw what looked like 2 entire invasion fleets heading for Calais. They shifted troops, repositioned artillery, and left the beaches of Normandy exposed. At dawn, when the real invasion began, radar once again failed to tell the truth. From science to strategy. By the end of 1944, the radar war had consumed enormous resources on both sides. It wasn't just about bombs anymore. It was about information, deception, and the control of perception. The British called it the Wizard War, a war fought by mathematicians, engineers, and quiet geniuses like Bishop and Curran, people who never carried guns, yet whose ideas turned the tide. Their inventions didn't roar like Spitfires or thunder like artillery. They whispered, through frequencies, reflections, and false shadows. But in that whisper lay victory. Forgotten heroes. When the war ended, the files on these projects were sealed. Bishop went back to his paint shop. Curran continued in physics, later contributing to radar astronomy. Neither received public recognition until decades later, when the declassification of documents revealed just how close their work had come to altering history. In the long list of wartime heroes, their names rarely appear. But ask any pilot who survived those nightmare raids, and they'll tell you they owe their lives to the invisible. The stealth legacy. The science of invisibility did not die with the war. In the 1950s, American engineers at Skunk Works revisited Bishop's early coating experiments. They called the concept radar-absorbent material. By the 1970s, that same principle produced aircraft that could slip through the Soviet radar web almost unseen. The first stealth bomber wasn't born in Nevada. It was born in a British paint lab in 1942. And that is the quiet truth of war. Sometimes the smallest mistake can hide the biggest secret. Fade out. The hum of radar fades to silence, replaced by a single heartbeat. This was the unseen war. The war that turned the night sky into a battlefield of ghosts. And its echoes still ripple through every radar screen in the world today.